In ancient times long gone by, scientists believed Saturn to be the most distant planet from the Sun. It was not until Sir William Herschel discovered Uranus in 1781 that anyone knew of the existence of planets beyond Saturn. Actually, Saturn is the sixth planet from the Sun, and it is unique in the solar system because it is the only planet lighter than water. It has a density of 0.7 grams per cubic centimeter, compared with water's weight of 1 gram per cc. Saturn's most distinctive feature is, of course, its rings, and the image on your screen represents the finest view available of them from Earth-bound telescopic systems. Much closer now, Voyager 1 took this photograph when the spacecraft was only 21.1 million miles from the planet. Dione, one of Saturn's inner satellites, appears as 3 color spots just below the planet's south pole. An abundance of previously unseen detail is apparent in the rings. For example, a gap in the dark innermost ring, called the C ring or creep ring, is clearly seen. Material is seen within the wide Cassini division, separating the middle B ring from the outermost ring, the A ring. The Encke division is shown near the outer edge of the A ring. This computer composite of 4 Voyager photos contains a wealth of new information on the rings of Saturn. Voyager 1 took the pictures while 25 million miles from the planet. Although the colors are false due to computer enhancement, color variations are real. Satellite Mimas is at the bottom edge of the photo. The bright spot to the right of your screen is just an artifact of processing. Portions of 4 of Saturn's rings can be seen here. The smaller arc-shaped feature in the lower right is part of the F ring discovered by Pioneer 11. The black dots, seen in this image and throughout the program, are rhizomarks, which are artifacts of the Voyager camera system. 2 small satellites of Saturn discovered by Voyager 1 are seen in this photograph taken by the spacecraft at a distance of 15.5 million miles from Saturn. The smaller, innermost of the 2 has a radius of about 155 miles and is seen near the bottom edge of the A ring to the left of your screen. It travels an orbit between the A ring and the F ring. The second satellite, seen just outside the F ring at the top of your screen, is about 186 miles in radius. This image of Saturn was color enhanced to increase the visibility of large, bright features in Saturn's north temperate belt. It is believed that these spots might closely resemble gigantic convective storms, similar to but much larger than thunderstorms in Earth's atmosphere. The largest violet-colored cloud belt is Saturn's north equatorial belt. The distinct color difference between this and other belts and zones may be due to a thicker haze layer covering the northern portion of the belt. Dark spoke-like features in Saturn's rings are seen revolving around the planet with the ring's orbital motion in these 6 photographs taken by the Voyager spacecraft. The images were taken in sequence, from upper left of your screen to lower right, approximately every 15 minutes at a distance of about 14.9 million miles. These spokes are not permanent. They appear for several hours and then disappear. They do not make a complete rotation of the planet as individual spokes. However, they are continually present as a feature. Saturn and 2 of its moons, Tethys above and Dione, were photographed by Voyager 1 from 8 million miles. The shadows of Saturn's 3 bright rings and Tethys are cast onto the cloud tops. The limb of the planet can be easily seen through the 2,170-mile wide Cassini division, which separates the A ring and the B ring. The view through the much narrower Encke division near the outer edge of the A ring is much less clear. This photograph of Saturn's rings, taken by Voyager 1 at a range of 8.19 million miles, shows complex structure within the Cassini division never seen before. Seen within the division are 4 bright ringlets, separated by darker components and an outer ringlet of medium brightness. All of these internal features are bounded by an inner and outer dark division. Such structure within the Cassini division suggests that some mechanism other than the interaction between Saturn's satellites and the orbit of the ring particles must be responsible for the detailed structure of Saturn's ring. This enhanced color image of the northern hemisphere of Saturn, taken by Voyager 1 at a range of 5.5 million miles, shows a variety of features in Saturn's clouds. Small-scale convective cloud features are visible in the brown belt. An isolated convective cloud with a dark ring is seen in the light brown zone, and a longitudinal wave is visible in the light blue region. The smallest features visible in this photograph are about 109 miles across. Saturn's southern hemisphere is shown in this false color image taken by Voyager 1 from a distance of 4.9 million miles. The color contrasts are an indication of the divisions between belts and zones in this region. The shadow of the satellite Dione is seen as a dark circle on the face of the planet. A large red cloud feature, 7,456 miles in length, is evident in the south polar latitudes and has been seen continuously by Voyager since August 1980. A computer assembled this two-image mosaic of Saturn's rings taken by Voyager 1 at a range of 5 million miles. It shows approximately 95 individual concentric features in the rings. The extraordinarily complex structure of the rings is easily seen across the entire span of the ring system. The 14th satellite of Saturn, discovered by Voyager 1, is seen at the upper left of your screen, just inside the narrow F ring. This F ring is less than 93 miles wide. The unique